All right, ninth grade students, Mr. Wagner here. Sorry, I am not here with you personally in class, but that's just the way it is today. We're going to go through some of the notes together in a video, and I just want to remind you, don't forget your element project is going to be due on Monday, so that's 1 week from today. So make sure you have that turned in, or at least ready to turn in on Monday. You'll be presenting on Monday. Anyway, I think this is about where we left off. Last time we were in class, we were going through some element family notes. We said element family 1 is the alkali family. We said that they all react with water. We watched a cool video where some of them blew up in a bathtub. Then we talked about element family 2. We said those are the alkaline earth metals. And right now we are at element family 13. Remember, we are skipping the transition metals in the middle. So element family 13, that is the boron family. So take a look at the slides. Make sure you're copying down these notes. The boron family. So let's talk about the boron family. Since it is in family 13, it has 3 electrons in their outer shell. And it bonds less readily than the alkali metals or the alkaline earth metals. That makes sense because remember we said all the way to the left that they bond very easily. They have 1 valence electron if it's an alkali metal or 2 valence electrons. Now we're talking about 3 valence electrons. We already watched a video on melting gallium. We may have already repeated this slide. So let's continue moving along. Now we're at element family 14. It's the carbon family. So it's got carbon, silicon, germanium, tin, and lead. Do you have to memorize all those? You do not. They have 4 valence electrons in their outer shell. And carbon is in tons of things. Actually, anything that is living has to have carbon in it. That's just the way it is. It's also in lots of non-living things. And there's a video here about the history of lead. We're not going to watch that together. There's nothing in here that is testable content, but essentially they're talking about lead has been used for all sorts of things, including long ago was used for plumbing. Well, they found out that people that used lead for plumbing went crazy. They got lead poisoning. Do people still get lead poisoning? Yes, not typically from plumbing, but young children do from lead paint. If there's paint chipping off the walls and a kid puts it in their mouth, there's enough lead in there to cause brain damage. So keep that in mind. Don't eat paint chips. Those are bad for you, and something seriously in the future with children, you want to make sure that they are not exposed to old paint chips. Let's move on. Let's go to the nitrogen family. And the nitrogen family, it's got 5 electrons, 5 valence electrons in their outer shell. Nitrogen, phosphorus, arsenic, antimony, and bismuth. And notice here we've got 5 valence electrons, and what I'm pointing to here is phosphorus. So there's white phosphorus and red phosphorus. White phosphorus is used, or it was used in grenades and used in warfare. White phosphorus, when exposed to air, immediately catches on fire. And in Vietnam, World War II, and things like that, there was grenades even used by the United States that were white phosphorus. As soon as it explodes, anything that it touches immediately bursts into flames. It's now illegal to use in warfare, but it is still being used in the Middle East, even though it's illegal to use. One of the reasons why it's illegal is because it's just a very slow, terrible way to die, and it's a weapon that induces fear. And I mean, all weapons are kind of scary, but this one in particular. Also, there's red phosphorus on matches. And nitrogen, turns out most of our air is made up of nitrogen. Arsenic, that's in rat poison. You don't want to mess with arsenic. That's just bad news for you. All right, let's continue. Let's go to the representative elements. The oxygen family, which are part of the representative elements. They have 6 valence electrons on their outside. And whoops, I feel like we should have said a little bit more about those. Here's sulfur down here. Sulfur is found in matches. Oxygen, of course, we breathe. Selenium, it's a mineral that is essential for people to have, especially older people. I don't know exactly why. Tellurium and polonium, I don't know a whole lot about those things, except polonium I'm pretty sure is radioactive. That is the oxygen family. Let's go on to the halogen family. You'd think it would be called the fluorine family, but it's not. It's called the halogen family. And the halogen family has 7 valence electrons in their outer shell, and they're also known as salt formers. Why? Sodium chloride for chlorine. Most salts have chlorine in them. So remember the salts that I burned in class and they made all those pretty colors? They all had chlorine in their end, and they were all salts. So the halogen family is the salt formers. And iodine, astatine. Here we've got some pictures in World War I. There were chlorine grenades and chlorine gas. You take one breath of pure chlorine gas, you're not going to recover from it. Again, that's another weapon that is illegal to use in warfare. That is still being used in the Middle East. It's very easy to make, and it's very, very deadly. So now you know a little bit about those, the halogens. Now on to the noble gases. The noble gases, take a look at their outer ring here. They have 1, 2, 3, 4, 5, 6, 7, 8. They have 8 valence electrons. Why is that a big deal? When you've got 8 valence electrons, you do not need to bond with anything else. You just don't need to. There's no reason to bond. So helium, neon, argon, krypton, xenon, radon. I'm in my basement right now, which has small trace amounts of radon in it. And how radioactive is that? It's up to 4 picocuries. I did some reading on that. It's not terribly dangerous. But these are all noble gases, and they are all completely unreactive. They simply do not react with anything because the perfect amount of valence electrons is 8. This has no reason to give up any electrons. One of their uses is that even though they don't bond, you can energize them, and when you do energize them, they glow and they make cool lights. So neon lights, sometimes they have trace amounts of krypton or xenon in them in order to get different colors. So runway lights here, we've got a runway, and these runway lights, they've got noble gases in them, and the noble gases, they glow and they look pretty neat. Anyway, there's some videos that go along with this. We're not going to watch those right now because we're not going to watch a video of me watching a video. But with one of the videos is, I forget, it's an actor. He's breathing in helium. He speaks very funny because it's high pitch. Okay, so helium is very, very light. So when you breathe it in, maybe you've done this with a balloon, you breathe it in, you talk out, you sound funny. Well, that's a very light noble gas. What happens if you breathe in another one like argon or krypton? Actually, the opposite is true. Instead of your voice going high, your voice goes low. So maybe sometime do a YouTube search for someone breathing argon or krypton, and it actually makes a very, very low sound, and it's hysterical. So anyway, transition metals. Okay, so remember the representative elements, those are on the outside. Those are the tall families. But now we're talking about the stuff in the middle, right? That's groups or families 3 through 12. It's the stuff right in the middle. Many are found in nature with other elements. Some, such as copper, iron, and cobalt, manganese, are important for body chemistry. So remember, it's these ones right here in the middle. We haven't talked much about those so far. But things like manganese, gold, silver, cobalt, iron, These are very important elements, but remember, they don't react the same way that the representative elements do on the outside. So they're their own group right there in the middle. Which ones am I talking about? I'm talking about these ones here. You see the stuff in blue right here? These are the transition metals. Now let's talk about the lanthanides. You see the word lanthanides up here? Lanthanides are these ones down at the bottom, right? So these green ones. And notice, if you're looking at the periodic chart here, we've got like a spot right here. Man, I wish I could move this right now. But we've got number, 56 right behind this arrow. And then it would go to 57, but 57 isn't here. 57 through 71 actually fit in that spot. Like all these elements fit in that spot right there. And then it goes 72, 73, 74, 75. So all those belong right there. What's the big deal about the lanthanides? Well, let's talk about the lanthanides. They're not a family because they don't go up and down, but they are their own. They're not their own period, but they're their own like group, I guess. Not necessarily a group, but their own sector of elements. It's elements 59 through 71, down towards the bottom of the periodic chart, and most of them are soft enough to be cut with a knife. And they used to be called rare earth elements. Why? Because people thought they were rare. But they're not. They're really not that rare. Let's go back real quick. Let's take a look at some of these things, like cerium, promethium, europium, terbium, erbium. Here's number 60, neodymium. You might actually have some neodymium at home. They're incredibly strong magnets. So if you've ever seen those toys that are really, really small and they go together, those are neodymium magnet toys. Actually, I think I've got some neodymium stuff right here. Hold on. Wait. Here it is. Ding, 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 ding. You ever seen these before? These chains of magnets right here. So neodymium is extremely, extremely strong. Now, are these pure neodymium? No, they are not. But neodymium is an incredibly strong magnet. So there's some neodymium in here. I forgot I had those. Thanks for reminding me. Anyway, let's keep going. And here's the neodymium. So they got the magnet right there. If you ever get bored on YouTube, check out neodymium. Neodymium can be so strong, they can be dangerous. All right, let's keep going. Now we're at the actinides. We're at the red stuff down here. Okay, so lanthanides were these ones. Those were the rare earths. And these ones are the actinides. Almost all of them are radioactive. Let's talk about the actinides. First off, not almost, they are all radioactive. Number 90 through 103, they're all radioactive. Thorium, protactinium, and uranium are the only naturally occurring actinides. So you're probably thinking, well, where did the other ones come from? The other ones are a byproduct of nuclear radiation. They're a byproduct of nuclear processes. So could you on Earth find most of the actinides? No. Remember, only these three are stuff you could dig in the ground with a shovel and find. But all the other ones, they're either made in a particle accelerator or they are made in a nuclear laboratory. So the remaining actinides are synthetic. If they're synthetic, they're made by humans. They're not naturally occurring. They're not found in nature. Synthetic elements are made in laboratories and nuclear reactors. And one of those is americium. Americium is a synthetic actinide that's used in smoke detectors. You probably have americium in your house, and it's in smoke detectors. And remember, I showed you a picture of Nuclear Boy once, and he was a Boy Scout that in his garage he collected some radioactive elements. The one he collected was americium. He ran, I believe, a smoke detector recycling drive. And he says, hey, if you guys need to recycle your smoke detectors, it's got radioactive materials, give it to me. Well, he started recovering americium from hundreds or even thousands of smoke detectors, and he was exposed to all sorts of radioactivity. So the americium in your smoke detector is very, very small amounts. It's not enough to hurt you or anything like that, but it is radioactive. Anyway, those are the actinides, and that is the end of this. So at this point, your notes should be done. There is another assignment. I believe it's periodic table detective or something like that. It's on Google Classroom. That is the next thing that you should be working on right now. So once you're done with these notes, go ahead and work on that. I hope you have a great day, and I certainly hope to see you on Tuesday.